Okay, in example 6 we have another example that looks at either compound interest or present value, so we need to determine which one it might be. And so it says, Sarah is starting a small business. She applies for a $10,000 loan, which she plans to repay in 5 years. The amount Sarah will owe when the loan is due is $13,439.16. And then it asks, what rate of interest, compounded semi-annually, is Sarah being charged? So, if we think about what's given in this case, we're told how much money she's invested initially. So, we know that she invested $10,000 initially, so that's my principal amount. We also know that in a span of 5 years, that amount will increase to $13,439.16. So that would be my accumulated amount. So in this case, we actually have the principal amount and the accumulated amount. And so what are we actually looking for? We're looking for what rate of interest, compounded semi-annually, that she is actually being charged. So let's start by looking at the compound interest formula. And again, I know it's compound interest because it says compounded. So that's the key word you're looking for in order to recognize that it might be a compound interest question as opposed to a simple interest question. And so she's making a one-time investment of $10,000, she's borrowing $10,000 once, and then she's going to owe $13,439.16 as a result. So let's start with the compound interest formula. Okay, and let's list the information I know. So I know the accumulated amount is $13,439.16. I know the principal amount is $10,000. Okay, let's take a look at the interest rate per compounding period. I represents the interest rate per compounding period. And so we don't actually know how much interest she's being charged on an annual basis. So we don't know what the interest rate is, but we know that it's being compounded twice a year. Okay, so the interest rate per compounding period would be R divided by 2. Because it's semi-annual, so I know that the interest rate would be divided by 2 to figure out the interest rate per compounding period. So eventually what we're going to be solving for is what the value of R is. Okay, so that's what we're going to be solving for eventually. Okay? Alright, the number of compounding periods. So, because interest is compounded semi-annually, that means we're going to get interest twice a year. And if we look back up at the question, she's planning on repaying this loan in 5 years. So that's times 5. Okay, twice a year for 5 years to give you a total of 10 compounding periods. So she's going to be paying interest 10 times over a span of 5 years. So if we plug in the information we know, and I'm going to leave I the way it is for now. Eventually, once I isolate I in the equation, I can use R over 2 to help me solve for R. So I'm going to leave I the way it is, but I'm going to plug in all the other information that I know. So I know that A is equal to $13,439.16. I know that P is equal to 10,000. And 1 plus I, I'm going to leave the way it is. And I know N is equal to 10. Okay, so what I'm trying to actually solve for is a value of I, which means I need to try to isolate this part of the equation first. And I can do that by eliminating the 10,000 that I have in front of it. And so the operation here right now is multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 10,000. And I get 1 plus I to the exponent 10 on the right hand side. And on the left hand side I get 1.343916. And now I want to keep all the decimal places because I want to try to get as accurate a solution as I can. So I'm leaving all the decimal places there. Now the problem here is that I have an exponent of 10. And if I think back to one of my previous units, Unit 2, in order to get rid of an exponent of 10, I have to find the 10th root. It's sort of like if you had the square root of x. Okay? What that means is if you're looking at the square root of a value, in order to eliminate the square root, you do the opposite operation, which is finding the square of that value. So it's a similar kind of idea. And so to get rid of the 10th root, the 10th exponent, an exponent of 10, what I'm going to do is find the 10th root. So find the 10th root of both sides. And so the 10th root on the right-hand side will cancel out with the exponent of 10. And so all I'll be left with is 1 plus I. And on the left-hand side, I need to do the calculation. On the right-hand side, it's already done. So 10th root of 1.343916 is about 1.03. And I'm going to round off my answer at this point because I know I'm going to just subtract 1 eventually. So I can round off my answer at this point. So to isolate for I, what I'm going to do is subtract 1 from both sides, and I get I is approximately 0.03. Now, I is just the interest rate per compounding period. However, the question is asking us to find the interest rate compounded semi-annually. So what I'm actually going to do is use this to help me solve for R. And so if I plug in the interest rate per compounding period into this formula, I get 0.03 is equal to R over 2 approximately. And if I cross multiply, so add my imaginary 1 underneath, if I cross multiply, I get R is equal to approximately 0.06. Now here is the interest rate that's being compounded semi-annually, and so this is the interest rate per annum compounded semi-annually. And so what this means is this is actually a 6% interest rate, and that makes sense. You're earning 6% per year, but you're only earning 3% per compounding period, or in other words 3% twice a year, semi-annually. So therefore, Sarah is being charged 6% interest per annum, compounded semi-annually. Okay, so in this case, this is actually how much she's being charged in interest. Normally we look at how much interest you earn. Because she's borrowing money, this is how much interest she's actually paying.